Hello everyone and welcome. Today in this tutorial, we will use R language to predict flight delay. This tutorial presents an end-to-end example of Synapse data science workflow in Microsoft Fabric. It uses the NYC Flight 13 data and R to predict whether or not a plane arrives more than 30 minutes late. It then uses the prediction result to build an interactive Power BI desktop dashboard. So let's begin with the lab. So first of all, go to the website app.fabric.microsoft.com. Then here we have to log in with our email address. Then it is the home page of the Fabric. So first of all, make sure that on the left hand side bottom here we can see the Fabric icon. So make sure that it is in Fabric. Sometimes it is by default come with a Power BI. So make sure it is Fabric. Then go to my workspaces. Then click on my workspace and here click on new item. And here you have to search for notebook. So if you see in the right hand side, there's a filter option, search option. So right here, notebook, and click on the note. So this is the home page of our notebook. So here you have to write some codes. So first of all, we need to install the packages. So I will install the NYC Flash 13 package. So first install dot packages, then colon NYC flights 13. Make sure that here the language is Spark R. So then here in the you have to press on the play button to run this cell. It will take some time to install this package. So let's wait. So you can see our session is ready and still it is running, and we can see the logs here. Let it execute first. So we can see our command is executed and you can see the logs here. So I will collapse log and then you can see the packages downloaded. Now we have to load the libraries. So first of all, we need to create a new cell. So press Shift plus Enter to create a new cell. And here in this cell, we have to write library tidy models. The next one is library, then NYC lights, .30, Then click on the play button to run this cell. It is running, so we need to wait. Done. So we have successfully loaded our libraries. So next we'll explore the data. The NYC Flight 13 data has information about 3,25,819 flights that arrived near New York City in 2013. First, view the distribution of the flight delays. The graph that shows distribution of arrival of delays. So, first of all, we need to make the graph. So, create a new cell by pressing Shift plus Enter. Then here we need to write the code gg plot. Then in bracket we need to write flights. Then arrival or delay. Then outside plus and demographic histogram in bracket. We need to give some colors. So let me give the first color be blue, and this is equal to say 300. Mm. Then press on the play button to run this cell. So we can see a graph is shown in the y-axis. The count of the flights is shown, and on the right, on the x-axis, arrival or delay is shown. So this graph shows that the distribution of arrival delay is right shift. This graph shows that the distribution of the arrival delays is right shift. It has long tail in high values. So you can see that it has long tail in high values. Next, we have to load the data, and we have to make changes to certain variables. So again, create a new cell. So press Shift plus Enter. Then here in the new cell, we need to write some code. So you can copy this code from here. Trade equal to 1, 2, 3. Then flight. Oops, sorry. Then flight underscore data. Then flights percentage data. Here mutate can copy this code from here. So let me write fast. So here's the entire code. Now we need to run this code, run this cell. So press on the play button to run this cell. So we can see the command is executed. Next, we'll build the model. So before we build the model, consider a few specific variables that are important for both process for both pre-processing and modeling, such as variables such as array delay is factor variable, variables such as array delay, variables such as array delay is a factor variable. For logistic regression model training, it's important that outcome variable is a factor variable. So next, we need to add a new cell. So here, write glimpse, then set the bracket. We need to write flight underscore data, and then click on the play button to execute this code. You can see the command is executed, and we can see the number of rows and column here. So we can see that next add a new cell. Again, press shift enter. Then here we need to write some code such as flight underscore data percentage, then we need to count the arrival delay. So here we are basically calculating the percentage of from the data set, that how many flights are late or for how much time flight is late. Here we need to write arrival, then delay percentage, then here we need to write mutate prop is equal to n divided by sum of n. Then we need to execute this code. So press on the play button to run this cell, and you can see the command is executed, and we can see the exact numbers that the number of flights were late and thus on time. Next, we'll add some features too. So again, create a new cell, and here we need to write unique flight data. So I need to write carrier, and then you need to run this cell also. So then press on the play button, so we can see the different levels, and we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 distinct carriers. So next thing is we will add another feature, unique So next thing is we'll split the data. So we'll split the single data set into two sets, a training uh, Hmm. a training set and a testing set. So keep most of the rows in the original data set as randomly chosen subset in the training data set, and use the training data set to fit the model, and use the test data case to measure the model performance. So we'll use the rsample. So we'll use the rsample package to create an object that contains information about how to split data. Then you'll use two more rsample functions to create data frames for the training and testing sets. So first of all, create a new cell, and here in the new cell, we need to write set dot seed train. And the next line we need to write data split initial split data into soft is equal to 0.75, and in the next we need to define the two data frames, two data sets, that is the train data set which belongs to training. Data split. And next we need to make a new split, that is test data belongs to the testing data underscore underscore split. Then we need to execute this command. So click on the play button to run this cell, and you can see the command is executed. So we have successfully split the data. Then the next thing is we'll create a recipe. We'll create a recipe and roles. Create a recipe for sample logistic regression model. Before training the model, we need to before training the model, use a recipe to create new predictors and conduct the and conduct the preprocessing that the model requires. We'll use the update underscore role function. We'll use the update role function so that the recipes know that flight and time are variables. इसको क्या कहते हैं रेसिपी कहेंगे ना कुछ होता है ना रेसिपी भाई मैं तुझे पता है मेरे को लग रहा है कि वो खाना we'll use the update role function so that the recipes know that the flight and the timer are variables with a custom role called id. A role can have any character value. The formula includes the variable in the training set other than the arrival underscore delay as a predictors. The recipe keep these two id variable doesn't use them for either outcome or predictors. So create a new cell, and here we need to write flight. You can copy the code from here. So let me write it fast. And then hit the play icon to run this cell. So this command is also executed. Next, we will summarize the flight records. So create a new cell, and here we need to write summary flights record, and then click on the play button to run this cell. So we can see the ID and the predictors. Next thing, we'll create some features. So we'll do some feature engineering to improve the model. The flight date might have reasonable effect on the likelihood for the late arrival. So we'll create a new cell, and in the new cell, we need to write this code. You can copy the code from here. Then press the play button to run this cell. So you can see the numeric date. Next, we will add 3 more steps for our recipe. So create a new cell and we can copy the code from here. And you can copy the code from here and press the play button to execute this code. So we are done till the creating feature part. Next, we'll fit a model with the recipe. So we'll use the logistic regression to model the flight data. So first of all, we'll build a model specification with the parsnip package. Parsnip package. So create a new cell and you need to write this code. So next, click on the play button. You can see the command is executed. Next, we'll use the workflow package to bundle the parsnip model with the recipe. So create a new cell and here we need to add the code. Then execute the code. Click on the play button and we can see so next thing is we'll train the model. So again, make a new cell and here we need to train the model. So this function can prepare the recipe and train the model from the resulting predictors. So first of all, we need to write the code, that is flights underscore set flights underscore flow. Then next write set then data equal to train data. Then press on the play button to execute this cell. It will take some time. So we can see our command is executed. So next we'll use the helper function, extract fit parsnip and extract recipe to extract the model or recipe object from the workflow. So in this example, we'll pull the fitted model object, then use the broom tidy function to get a tidy table of the model coefficients. So let's create a new cell and you need to write the code from here. You can copy the code from here and click on the play button to run this cell. So you can see our command is executed. Next, we need to predict the result. So single cell, so a single call to predict a single call to predict uses the trained workflow flight fit to make prediction with unseen test data. The predict method applies to recipe. The predict method applies the recipe to the new data, then passes the result to the fitted model. So you can add the another column from here also. If we click on the code, so it will create another cell. So in this cell, we need to write predict, inside it write flight test data, then click on the run cell option. Then click on the run cell option. So it will take some time. Done. So our command is executed. Next, we'll get the output from the predict to return the predict class, late versus on time. So however, the predict class probabilities for each flight use an argument with the model. So combine the test data to save them together. So next we'll add a new code. Next we'll next we'll add a new cell, and in this cell we'll write the code. So you can copy the code from here. Then click on the run cell button. So it will take some time for running. Done. So our command is executed. So let's review the data first. So again, click on the code to get a new cell, and in this cell we need to write the glimpse flight, then click on the run cell. Then click on the run cell, and we can see before it has 10 columns, and after that we have added 3 more columns. Now it has 13 columns right now. So next we'll evaluate the method. Next we'll evaluate the model. We now have table with the predicted class probabilities. In the first few rows, the model correctly predicted 5 on 5 flight, 5 on time flight. However, we have 81,455 rows total to the predict. We need a metric that tells how well the model predicted late arrivals compared to the true status of the outcome variable. So we'll use the area under the curve receiver or operation characteristic, that is the AUC rock, as the metric, and compute it with the rock curve and rock awk from the yardstick package. So first of all, create a new cell, and here we need to write the following command, and you can copy the command from here and press on the play button to run this cell. So we can see the graph is shown. Next, we'll build a Power BI report. So the model result look good. Uses the flight delay prediction result to build an interactive Power BI dashboard. The dashboard shows the number of flight by carried and number of flight by destination. Next, we'll create a Power BI dashboard. So we need to write a new cell, and in this cell, we need to write some code. You can copy the code from here and press the run cell button. Then let's review the data. So again, click on the code to add a new cell and write the command glimpse. Writes clean. Then run this cell too. So we can review this data. Next, we'll convert the data to a Spark. Next, we'll convert the data to a Spark data frame. So add a cell and write the command. And run this cell too. Still running. So we can see the Spark job is in process. If we see in this, so we can see the table over here. So next we'll write down the data into a delta table for a lakehouse. Again, create a new cell and write the code and click on the run cell button. It will take some time.